In this video, we're going to be identifying and evaluating polynomial functions. To start off with, we have to look at a lot of vocabulary and make sure we're all on the same page when we look at and try to describe a polynomial function. Let's first break down the word polynomial. It's got two parts. The first part, poly, just means many. And the second part, nomial, literally just translates into terms. So we're looking at polynomial functions. We're looking at just these math expressions that have many terms. And by the way, terms are just math expressions that are separated with a plus or minus sign. So when you look at the example that I gave you, it has a bunch of terms here. The first one is 7x to the fourth. Then there's a minus sign, so this is the second term. Then a minus sign, this is the third term. Plus sign, fourth term, minus sign, fifth term. This has 5 terms. So it's got a lot of terms. You can have polynomials with as little as 1 term or as many terms as you wish. We won't go crazy in this class. 5 terms is about as large as you'd ever really see from me probably. And I'm giving you one that's large so that we can kind of really explore this vocabulary a little bit more in depth. Let's first make sure we know what standard form of a polynomial is. That just means we're writing the polynomial in order from the highest to lowest exponent. So we're going from highest to lowest exponent. So the one that I gave you already is in standard form. As you can see, I have the x to the fourth first, then the x cubed second, x squared, x, and then just the number goes at the very end. So we do have it in standard form, and that's key when we identify the following vocabulary. Let's start off with the coefficients. Coefficients are just the numbers in front of the variable. In front of a variable. So from the example, we have a bunch of coefficients because there's a bunch of variables. The first coefficient is in front of the x to the fourth. That's a 7. The next one would be negative 3/5. The next one is an interesting one, negative square root of 2. And then we have positive 4/3. And that last one is kind of tricky. It's technically not a coefficient because it's not in front of a variable. That guy, that negative 5, has its own special name. That's called a constant term. So I'm going to go ahead and drop that down at the very bottom there where it says constant term. A constant term is called that because it does not change. It is not influenced by the value of x. If I plug in any values of x, all of these other terms can change their numbers based on what x is, but negative 5 is going to stay constant. It will not change no matter what value of x you plug in. So the constant term has no variable. It is just a number, just a naked number. Just a number, okay? Oops, didn't want to do that. All right, let's go to the leading coefficient. The leading coefficient is the most important coefficient. I'm going to go ahead and circle this one. Very, very influential when we talk about graphing and so on, and you'll see that in the next video. But the leading coefficient is your first coefficient. That's why it's called the leading coefficient. Now, that's, let me make sure I spell this right. It's the leading coefficient if it's in standard form. And in the example, that's 7. It's the very first thing that you see if it's written in standard form. It's the number in front of the highest variable. Now, exponents, you guys already know the definition of an exponent. That's the number in a power. The number in a power that tells you how many times the variable is a factor. So that tells the number of factors there are of the base, whatever that happens to be. And in polynomial functions, that's going to be a variable. So the exponents in the example start with a 4, then the next exponent is 3, then we have a 2, then a 1, and then that's it. Now, if it's in standard form, it should go from, descending order, highest down to lowest. The degree is the most important exponent. This is the largest exponent. And once again, this tells you a lot about the polynomial function. It's the most influential of all of the exponents. So from the example, we would say it's degree 4. Let's go to the next slide, which we're going to talk about a couple key types of polynomials you need to know. And they're all based on the degree, which is, of course, the highest exponent. If you have a degree 0 polynomial, we call that a constant polynomial. And I'm going to give you some examples in standard form. So for example, I might have something like y equals 3. Now, that doesn't look like much, but it's called a constant because if you think about it, if the equation just equals a number, it stays constant. Notice it's also a constant term. There's no variable next to it. The reason why it's degree 0, think of it this way. I could write x to the 0 power next to it. Now you can see the degree, but isn't x to the 0 from what we learned last section, isn't that really just 1? So if it's 3 times 1, you don't need to write that. It just stays 3. So technically, a function that just is a number is a polynomial. The smallest and most basic of all polynomials where the degree is 0, it's called a constant. If the degree is 1, you're doing pretty much all Algebra 1 stuff. This type is called linear. This is what we spent chapters 1, 2, and 3 discussing. An example might be y equals, 7x minus 5 halves. The highest exponent you see would be x to the first. You guys know you don't need to write that exponent of 1. It's implied that it's x to the first, but that's just a linear function because when you graph it, it creates a line. The degree of 2 creates what we talked about all during chapter 5, quadratics. So this type is quadratic. An example in standard form, you guys are going to really recognize these. Y equals negative 2x squared minus 5x plus 1. Let's say that's a quadratic written in standard form. In this chapter, we're going to get even more interesting and look at higher degree polynomials. 3 is called a cubic, because when you raise something to the third, we say it's cubed. So an example here might be y equals x cubed minus x squared plus 6x minus 4. That's written in standard form. Highest power there is 3. And the last one you're going to need to know the name for is a degree 4. That's called a quartic. A quartic polynomial in standard form might look something like this. X to the 4th minus 5x cubed. That's a 3 plus 6x squared minus x plus 1. Okay, actually the example at the very top was a quartic. If you remember, that degree was 4. What I'm going to ask you in homework and on a quiz or even a test would be some just basic vocabulary. I'll give you a polynomial like in example 1, 2x minus 3, and you're going to have to identify some vocabulary for me. What is the degree? Well, the highest exponent you see isn't written there, but you should know that's x to the first. The leading coefficient is the number in front, that's 2. Constant term would be negative 3. And the type, remember, is all based on this degree. And if the degree is 1, hey, that reminds me it's linear. So the type would be linear. If we were to graph that, that's just a line. Let's look at example 2. This one's a little bit interesting looking. F of x equals x plus 3x squared minus pi. Let's write it in standard form. That would be f of x equals, let's start off with 3x squared first, then plus x, and then minus pi. What's the degree? 2. Leading coefficient, 3. The constant term is negative pi, and the type, because it's squared, the degree is 2, we would say that's quadratic. Okay, let's move on to evaluating polynomials. We're going to learn how to evaluate polynomials in 2 ways in this particular video. The first way is going to be just by direct substitution. So let's write that here. This is going to be direct substitution. And I'm not going to show you anything new actually. When we do direct substitution, if I give you f of x equals x to the fourth times the square root of 5, if I want to find f of negative 1, you guys all know that just means plug in a negative 1 for x. Very important is everywhere you see a variable, start off with putting just parentheses. So if I'm evaluating this, I'm going to first start by just putting parentheses to the fourth times the square root of 5. Then I'll drop in the negative 1 afterwards. Now, when I evaluate this, I have to follow order of operations, and I know that I would have to do the exponent first, and I know a negative number to an even power will be a positive, and negative 1 to the fourth would be just positive 1. And then I have to multiply that to the square root of 5. 1 times the square root of 5 would just be square root of 5. So I've evaluated it just doing direct substitution. Let's look at example 2. I have f of x equals 5x cubed minus 12x squared minus x plus 5. If I'm finding f of negative 1, I'm going to rewrite everything with, instead of variables, parentheses. So it would be minus 12 parentheses squared minus parentheses plus 5. Then I'm going to drop in a negative 1, negative 1, negative 1, so I can try not to make any mistakes with the negatives here. I'm going to start off by cubing negative 1. Now negative 1 to an odd power is going to stay negative 1. It's negative 1 times negative 1 times a negative 1. So I really have 5 times negative 1. And now over here, for this term, I have to square negative 1, so that becomes positive 1. So I'm going to end up with negative 12 times a positive 1. Then I have minus negative 1. You guys know that's just plus 1. And then I'm going to tack on the plus 5. So at the end of the day here, I have negative 5 minus 12 plus, I'm going to go ahead and add these together and get 6. Negative 5 minus 12, negative 17. Then I can add 6. I get negative 11. So here, f of negative 1 equals negative 11. That's direct substitution. I'm going to show you a fun, fast way of doing the same thing in a completely new style. Something called synthetic substitution. This is pretty cool. I wrote down the steps here, and we're going to apply them to the example we just did. So I think the example we just did was this guy. We're going to do f of negative 1. What I'm going to do is first write down all of the coefficients of f of x. You have to make sure it's in standard form. Very, very crucial. If you don't have the polynomial in standard form, you can't do direct or the synthetic substitution. So I'm going to copy down the coefficients 5, negative 12, and then I have a negative 1 in front of the x, and then a positive 5. Okay, now I'm going to drop the first, and then I'm going to draw a line like this. And make sure you leave a little space underneath those coefficients. I'm also going to drop the first coefficient under the line 5. I'm going to write the number I want to substitute, that negative 1, in a little box kind of up into the left corner of the problem. So this is the number I'm trying to evaluate, negative 1. This is kind of how we start the process. So you drop down the leading coefficient on the line. Then I'm going to multiply negative 1 times that number, negative 5, negative 1 times 5, and I write the result over here. So when I multiply negative 1 times 5, I get negative 5. Then I add these together, and I get negative 17. Now I'm going to do the same thing. I'm going to multiply negative 1 times the negative 17, which gives me positive 17. So what I did there again is I multiplied to the negative 1 to get the 17. When I add them, I get 16. Now I'm going to multiply negative 1 times the 16, and I get negative 16. And when I add them, I get negative 11. Guess what? Doesn't that number look familiar? I think that was the result from the last page. When we plugged in f of negative 1 using direct substitution, didn't we get negative 11? That wasn't by chance, folks. That ending number at the very last step will be your solution. Let's do another example. And this one's kind of cool because you have to do something special. If you take a look at f of x, it's got an x to the fourth term, but do you see an x cubed term anywhere? Do you see x cubed anywhere? I don't. So the x cubed term is missing. So what you need to do is realize if there's a missing term, you kind of need to think of it this way. It's like 2x to the fourth plus 0x cubes. 0 times x cubed just wipes it out. That's why we don't see it. And then I'm going to write down minus 8x squared plus 5x minus 7. Now if you think about it, I have all of the exponents in order from 4, 3, 2, 1, and then my constant. That's what you need to see to set this up. I'm going to write down my coefficients: 2, 0, negative 8, 5, and negative 7. I'm going to put a line. Now remember, whatever we're trying to evaluate, that goes in a little box in the upper left corner. I'm going to put 3 in the box. To get this started, I'm going to drop down the 2, and then I multiply it to the 3. So 2 times 3 makes 6. I put the result here. Then I add 0 plus 6, and I get 6. Then I'm going to multiply 3 times 6, and I get 18, and I add. I get 10. Then I'm going to multiply by 3. That gets me 30. 5 plus 35, or excuse me, 5 plus 30, I get ahead of myself, that's 35, right? And if I multiply that times 3, 3 times 5 is 15, plus 3 times the 30, 90, 90 and 15, I think that's 105. And if I add 105 and negative 7, that'd be like 105 take away 7. What is that, 98? So my final answer, if I wanted to find f of 3, I would get 98. This takes a little practice, and I think the first time students see this, it is a little bit tricky. So go ahead and feel free to rewind and look at it again to make sure you can kind of follow the steps, because what I'm going to ask that you do right now is you're going to do your self-quiz. I have 4 quick questions. Some of them are just some vocabulary. I want you to do one problem where you're doing direct substitution. That's the old school method that you know. And then I'm going to challenge you to try to do synthetic substitution, and we'll see how you do in class tomorrow. Thanks for watching.